Good day, students. You're welcome to today's contact class. My name is Edu Triumph. Probably some of you, this might be your first time of meeting me. I am the new tutor for this course, Computer Studies, for the Advanced Certificate in Secondary Education. Advanced Certificate in Secondary Education, Computer Studies. Today's presentation is examination-based content class. So Mr. Edo is going to take you through what is expected of you for the next forthcoming August examination. So I'm going to be the pilot of this program, of this flight today, while you sit down listening attentively to me. Are you ready for the examination? Come on, man, don't be panicked. Don't get panicked, don't get worried. Examination is just to test probably what you know or what you already know. So you don't need to be nervous, to panic, or what is going to come out, what is not going to come out. What is going to come out, you know already. I'm only here to remind you and to guide you. Okay, computer studies for the Advanced Certificate in Secondary Education. You're going to see 9 questions in the August examination. You're going to see 9 questions. That does not mean it's only going to be 1, 2, 3, 4, 9. No, you can see 9A, 9B, 9C. So 9 questions with an aggregate of 120 marks. With an aggregate of 120 marks, you are required to answer all the questions. You will be required to answer all the questions. But in order for you to do effectively in answering the questions, go back to your study guide and read through those examination terminologies, those examination terms, phrase, like state, explain, differentiate, outline, define, discuss. Your understanding of these words or this term is very necessary when it comes to the examination, because there's always a difference between when we say differentiate and when we say discuss. So you need to really understand what is expected of you when those words are used. For example, if I say outline, or list, for example, list hardware that you know is different from discuss hardware known to you. These are two different things. So don't always take the examination terms for a ride that you know. Read them so that you can get used to their meaning, because definitely they will help you on how to answer your questions. Okay, now let's come to what is expected in computer studies for the Advanced Certificate in Secondary Education in August examination. You see what I have written on this slide, I made it bold, I made it capital letter, I made it big. Why? Because I want to emphasize that point. And what is that point? The point is the examination covers the entire syllabus. I repeat, the examination covers the entire syllabus. So this presentation does not substitute your study guide. This presentation does not substitute your study guide. It's not a substitute for your study guide. So don't limit yourself to this presentation. This presentation is just a guide. It's not a study guide. It's just to guide you on what is expected, what you should do. So don't say, Mr. Edo, I see a question in the examination that is not in your presentation. My presentation is not a study guide. My presentation is not examination question paper. That's why I want to read it again. The examination covers the entire syllabus with questions selected from all modules. The whole course outline is covered. So you're expected to know everything there. But what I have done in this presentation is that I have selected 1 or 2 topics to treat with you. What criteria did I use in selecting this topic? These are topics that can pose problem to you when it comes to understanding. It doesn't mean these are topics that your questions will come from, but question can come from that. So as a computer tutor, about 19 years in tutoring computer, I know students have problems when it comes to algorithm, flowchart, programming. So that is why I selected this area. Not that the examination comes from these topics. The examination covers everything you are expected to know. Okay, let us look at some of these things that I have here for this presentation. The first thing that Mr. Edo is going to talk about is flowcharts. I'm sure during your assignment you must have come across flowcharts. And during your personal study you must have come across flowchart. So what is a flowchart? What is a flowchart? A flowchart is a type of diagram that represents an algorithm. What is an algorithm? Algorithm is a step-by-step solution to a programming problem. Some of you must have written an algorithm before, maybe you're grade 10 or you're grade 12. So you have an idea of what I'm talking about here. That is, if you have a question, a programming question to solve, you have a programming question to solve, it's always good you write the algorithm first, then put in your flowchart. So a flowchart is a type of diagram that represents an algorithm. It also shows the step-by-step solution to a programming problem. In a very simple way, it means a diagrammatic representation that illustrates a solution to a system that is to be designed. Okay, that is what a flowchart is. Now, in doing that, in drawing up a flowchart, if you are going to draw up a flowchart, first of all, you need to understand those symbols that we use when it comes to flowcharting. I love this topic. I love programming. It's quite interesting. I know some of you might say programming can be frustrating. I know it's a little bit logical, but it's quite interesting if you understand the fundamental, the indices, the things that can really help you. Okay, let's look at these flowchart symbols that you see on the screen. You need to know and draw each of these symbols. The first one there, you talk about the data. Okay, you talk about process, decision, start and end. Just look at the flowchart symbol. Please, I want you to take note. This one that has to do with data, mostly it is called input and output symbol. Okay, so you can call it input and output symbol. All right, so whenever you are going to represent an input or you are going to represent an output, you always use this symbol. If you are going to represent a process taking place, process taking place can be when some calculations are taking place, some process is happening, then you use this symbol. Whenever a decision is supposed to or is going to be made, when a decision is going to be made, you use this symbol. Then start and end, you use this symbol. Those are common ones, although we still use all these other ones. But the input and output, the one I'm using the mouse to wave at, the input and output, the process, the decision, the start and end, those are very common symbols that we use, especially at the grade 12, grade 10 level of the secondary school education. So what Mr. Edo have done is I brought in a flowchart here. I extracted this from one of the questions, designed it to teach you how to answer questions when it comes to flowcharts. How do you answer questions? Read through the instruction. And what is my instruction? It says walk through the following flowchart and complete the trace table on page 17. Okay, in my presentation there's no page 17. I took this from one past question paper, so ignore that word 17. Let me read the instruction again. It says work through the following flowchart and complete the trace table using the following data. So you see a flowchart like this. We say, wow, this is a lot of diagram. You get confused. Now you get confused. Where do I start from? My dear, sit down. Mr. Edo will teach you where to start from. The journey of 1 million miles start from a place and it's going to end at a place. So the question is, where do you start from? Okay, but bear in mind, a table must have been given to you. So in answering this question, a table will be provided to you, and you know what a table is, né? As a computer student. Okay, a table is where you have columns, né? I'm trying to draw up my table here just to illustrate to you how to fill in the table. It's quite simple. As I always tell people, it's just as easy as eating kapana, né? I don't know, it's difficult to eat kapana, no. Alright, so I want to assume this is my table given to me in the examination hall. Alright, let me finish drawing my table. Good, here I have a table. Alright, okay, and place it properly from good. Now, where do you start from? Can you look at your flow chart? You see the word, a symbol there says start. That is your starting point. You say start. That is your starting point. So you are going to start from there. Can you see that now? You are going to start from there. Now, in your table, you will be given the variables. So I will have my variables here. I already solved it, as you see on the screen here. I already solved it, but I will not just give it to you. I'm going to tell you how I solve it. So I'm not just going to give you a solution, but I will tell you how to get the solution. I hope what I have drawn will be enough. I hope so. Otherwise, I'm going to redraw this again. Okay. Average 2, average 1, then I'll take this to be my output. Okay, it's not enough, but I think I'm going to manage the paper instead of me drawing it again. So you have the table like this. The table will be like this, blank, but the variables names will be on top. The variables name will always be on top. So your work is to complete this table. So how do you complete this table? Let's go back to our flow charts. The first thing there is a start. So let's start. Then you have the first symbol after start here. You don't put your start on the table. Okay? So the first thing is start. Remember, this is a variable. What is the name of this variable? It's neg. It's a neg is what? 0. So you come to your table. Neg is, you put 0. What else do you have? N is 0. N is 0. What else do you have? Pos, P-O-S, which is 0. Then what else do you have? P is 0. Can you see now? Box 1, which box is that? Let's just call it 1, because if you look at my box, they are already numbered here. 1. At times your boxes are numbered, at times they are not numbered. Okay? Alright. Mr. Edo, why did you put all of them on the same line, Mr. Edo? I put all of them on the same line because if you look at my flow chart, they are all in the same box. That is why I put all of them in the same line. From there, where do I go? Can you see this arrow? This arrow will always point to you where to go. It's the direction of flow. The direction of flow. Just like when you drive on the road, there is something on the road that tells you drive this way, go this way, directing you. So the arrow always directs you. And you know what? In algorithm, your program flows from up to down. In flowchart, it flows from up to down only when there is a decision to be made. So now that I'm done with that, the arrow tells me comes here. Then I come there. What do I have there? It says count is equals to 2. Count is equals to 2. So you have line in the second box. Where is count? Look at your table. Where is count? Count is here. Can you see now? Count is here. So what do? Under count, you put 1. So count is equals to 1. Sorry, not equals to 2. So I put 1 under count. Did you see that I did not write it on this line? Because it's on the second box. Okay. From there, it takes me to the next one. Input X. Input X. That is the next one. 3. Input X. Now the question is, what is my x? My x, these are the data given to me here. My x are 5, -3, 0, -3, 7, 0, 6, and -11. Those are my x. At times it can be input x, at times read x, at times, sorry for that, sir. Let me repeat that again. At times it can be input x, at times read x, at times enter x. So if you see a question that does not use the word input, and you see the word read, you see the word end, they're still the same thing, right? And where are the data? The data are the ones you see here. Now coming back to the flow chart, we say input x. So my first x is 5. So you come to your variable. See, these are your variables, okay? All right, x. The next line here, I'll put 5. It's always good you take your pencil after you use the data to cancel it or to stroke it so that you don't use it again. Just use your pencil to stroke it so that you don't use it again, okay? Now we are done with this. Where is the arrow telling us to come? The arrow says come to this box. I need to say one thing about this box. The next one, which is dissection. Dissection. You are going to decide. And you know why? The dissection box, let me just draw it here so that you can see it properly. The dissection box, which is always of this shape, all right, always have 2 arrows. Others have 1, but this one has 2. 1 pointing this way, 1 pointing this way. Because you are going to decide, there is always a question. What is inside the box is a question. Even if there is no question mark, turn it to a question. And when you ask a question, your answer can either be yes or no, true or false. All right, your answer can be true or false, yes or no. So if your answer is no, goes with the arrow that says no. All right, if your answer is yes, goes with the arrow that says no. Can you see that now? So if you look at it, it has 2 arrows. One for the yes or one for the no. One for the true, one for the false. I always tell my student, follow where the arrow says based on what you decide. And you know what? To help you understand how to decide, I always advise my student to turn whatever that is in the dissection box to a form of a question. Turn it to a form of a question so that it can make sense to you. So look at the way I'm going to turn this to a question now. It says, is x less than, this is less than in mathematics, although I'm opposite you now, so you might get me wrong, I'm opposite you now. So is x less than 10? What is x? Go back to your table under x. Under x, what do you see? 5. So let's do it mathematically now. Is 5 less than 10? Yes or no? Yes. Can you see now? So you come to under dissection because you are deciding. Is it yes? What did we get? Yes. Because we ask, is 5, that is x less than 10? Yes. So you write true there. Can you see the way I'm creating my table now? Very easy to fill up a table. Then if it is true, where should we go? Here or here? We should come here. This is yes. So you go with the arrow. Can you see that now? So that one becomes 5. So that one has an equation inside. And what is that equation? The equation is neg plus x. You see it now, neg plus x. You go back to your table and see what is neg. If I come back to my table here, see my neg is 0. Can you see now? So we say neg plus x. So 0 plus what now? X. What is x? My last x is 5. Meaning my neg now is 5. So under neg, you write 5. There's still another equation inside it. You say n is equals to n plus 1. What is my n? My last n is 5. I mean 0 rather. My last n is 0. 0 plus 1, it is what? 1. So n is now 1. Can you see now? So everything under n will always come under n. Can you see? Then we are done with this. Then you follow your arrow. Follow your arrow. Can you see where I'm tracing my arrow? The arrow says come this way. Always follow your arrow. I follow the arrow down here, it comes here. Now the next thing says count is equals to count plus 1. The question is, what is my count? My count is 1. Can you see that now? My count is 1 here. So what am I going to do? I say count is equals to count plus 1, which means 1 plus 1. So that gives us what now? 2. Meaning my count is now what? 2. You write it under count. You write it under count. From there, let's look at our arrow. It comes here. Can you see that now? It says is, this is a distinction, you are going to decide. Yeah. Is count less than 11? True or false? What is count? My count is 2. So is 2 less than 11? True. True. So you write down under distinction. True. You decided there, under distinction. True. Can you see now? You write true. If it is true, that is, if it is yes, where must I do? I go like this. Follow the arrow, follow the arrow. I always tell my student, follow your heart. Follow your heart, follow the arrow. Can you see where I'm tracing the arrow? It comes here again. Did it go up? No. It comes down. And what is it saying? Impute x. Remember, what are my x? These are my x. Can you see? And remember, we've used the one. The next one we're going to use is what? -3. So you come under x, then you will now say impute s -3. You put -3. Then you start the whole process again. Can you see now? That is how you will continue filling the table until you will come to an end here. Quite simple. I wish I have time to finish it with you, but I'm already 5 minutes over time of this presentation. Fortunately, I have 30 minutes for the presentation, and this is already 9:34. Okay, and I still have other things to show you. But it's quite simple. What I'm probably going to do is I'm going to design a content class presentation on this thing. But just follow what I have done and see how you can. So just continue like that. Now, if I say the last thing I did here was -3, you say read x. Impute x. Then if I come here, remember my x is now -3. So I ask, is -3 less than 10? Is -3 less than 10? Yes, because anything negative is always less than. Yes, you follow this way. Can you see that now? So it will come to a time, it will be no, just like that. Follow it until you come to an end. All right? So that is that about flowchart. Try it on your own. Complete what I have started. Then you are going to have a table like this. You are going to have a table like this. That is the product we are going to have. Let's look at another area, which is algorithm. This one is always given to you in the examination. It must always be there. I'm not saying the same variables, the same numbers. No, it's not going to be the same variable, the same numbers, but the same, algorithm must be there. Algorithm must be there, but not the same variables, not the same values. All right. Now, I'm going to solve only 1 or 2 because of time. I wish I can take, let me look at the one I can. Let me just take 1 or 2 because of time. Okay, let me start with the first one. When you see an algorithm, read the instruction. The instruction says, what will be the output after the execution of each of the following algorithm statement? What will be the output? That is, what is going to be your answer? I want to see the answer. When you execute this, all right, I want to see the answer. So how do you go about it? You draw a trace table. A trace table will help you to get your answer. a trace table. So I'm going to draw my trace table. Pay attention to Mr. Edo, as Edo is drawing a trace table. Remember what a table looks like? This is my table, okay? But here, in the algorithm, you are going to put in your variables yourself, unlike the flowchart where your variables will be given to you, okay? These are very simple things, as iti kapana, my dear. They are not difficult, okay? All right, now let's look at what are my variables. The first thing you should have there is line, okay? My first variable is total. The next variable is count. Can you see them? This is where I'm taking them from. Can you see them? Those are my variables. The next variable is number. The next variable is dissection. I will tell you why we have a dissection there. Then which other variable do we have there? Output. That is the next variable, is output. I think it's better you place it like this. Okay. So what do we do here? You need to understand which programming statement is in this program. The statement I have here is repeat until. From your study of algorithm, repeat until is a looping statement. It's a looping statement. That is, it makes the compiler to repeat certain instructions continuously until a certain condition is met. In a very simple way, it means, computer, please repeat this. Can you see that now? Repeat this until count is equal 7. Meaning, until count is equal 7, the compiler will continue to repeat this. Can you see now? Compiler will continue to repeat it. I will find time to teach you more about programming. Okay, so how do we start? We start like this. Number your algorithm to make it easier for you. Unfortunately, I will not be able to write on the screen here. So this total, which will be 1, the count will be 2, the number will be 3. All right, the total will be 1, the count is 2, the number is 3. You don't number repeats. Okay, you don't number repeats. Please take note. You don't number repeats. You number this one again. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You don't number repeat. It's just there to guide your program. So you start 1. Total is 6. 2. Count is 5. 3. Number is 6. I'm just putting them under the variable's name. Then you come to 4 now. 4 says total is equal to total plus number. What is total? 6. What is number? 6. So total plus number, 6 plus 6, that is 12. Meaning total is now what? 12. You come to the next line, okay, which is line 5. Then you say count is equals to count plus 1. What is count? My count is 5. Can you see now? My count is 5 plus 1. Count is now what? 6. In line, let me create more space. Create more space here. In line 6, my count, what I say is my count. Count is count plus 1. That is 6, 5 plus 1. So my count is now what? 6. Then this until you are going to decide. So this is how you decide. Is count equal 7? That is, those are the things you put on the dissection box. You say, is count equal 7? True or false? Count is what? 6. My count is 6. Is it equal 7? No. So under my decision, I put F, which means it is false. It is false. If it is false, you go back again. Can you see that now? It is false, you go back again. Because it says, repeat this until this is true. So we got false. What do? You go back now. So where do you go back to? You go back to here. You are going to be repeating between repeat, and until. That is where your looping is. I wish I think it's better I draw it for you. So if I think that is going to be the last thing I will do, let me write it here so that it will make sense for you, because I know how tricky this can be. This is what I'm saying. Number is 6. Here you have repeat. Okay. You have total is equals to total plus whatever. You have count is equals to count plus whatever. There you have until. Okay. Thank you. You have until count is equals to 7. There you have output total. I'm just trying to have here. So basically this is 1, 2, 3. Okay. This is 4. This is 5. This is 6. Can you see how you must number it now? Then you must sketch where your looping is. Your looping is always between repeat and until. This is where your looping is, which means whenever you are going back, if it is false, you go back to line 4. Can you see that now? You go back to line 4. You do what is here, you do what is here, you come back, you test your condition. If it is false, you go back again to 4. You do what is here, you do what is here, you come back, you test. If it is false, you go back here. Once it is true, you stop. Okay? So that is how to solve when it comes to repeat until. Repeat until. Please go and practice this. I will really speak to my coordinator to give me time to do a thorough presentation for you about algorithm alone, to have a really enough time on it. Okay, unfortunately I cannot take more than this because I've run about 10 minutes overtimes on this presentation. Beloved student, practice also about Microsoft Excel. You cannot escape question on Microsoft Excel. Practice on Microsoft Excel, practice on Microsoft Access. See, these three things are they are always there. Number one, you must see a question on a program. You must see a question on a flowchart. You must see a question on algorithm. You must see a question on Excel. You must see a question on Access. Those 5 things I mentioned, they must be there apart from other things. I repeat, Excel, Access, algorithm, flowchart, programming, and any other question taken from your course outline. But these 5, they must be there. So practice on Excel. The focus on Excel is how to write formulas, how to use formulas. That is always most of our focus. Beloved student, if you have more problems, which I know you are going to, please free to contact me on the number displayed on the screen. Before your examination time, I will always be there to help you. All right? Thank you.